Welcome to Brain Vision.
Problem 760. A sled with rider having a combined mass of 125 kilograms travels over a perfectly smooth icy hill, so no friction. How far does the sled land from the foot of the cliff? So we're supposed to take our rider, they go up to the top of the hill, that's 11 meters, and they go off the cliff, and they go out to some distance x, following a standard parabolic arc. So how are you going to solve this? So the first thing basically what we need to do is we need to find what our velocity is going to be up here, and I'll write that as v2 since this is v1. And then we're going to have to see how much time it takes to fall to see how far away the sled lands. So first off, you need to find what v2 is. I'm going to set up the conservation of energy formula. We only have kinetic energy here. If we define this to be our UG equals 0, so we have just K1 is equal to U2 plus K2, where 1 is this point here and 2 is this point here. So initially we have 1/2 times 125 kilograms times 22.5 meters per second squared. And that's going to be equal to the potential energy at 11 meters. So that's 125 kilograms times 9.81 meters per second squared times 11 meters. And then that's going to be plus the K2. So that's 1/2 125 kilograms v2 squared. Okay, so after that, we can find what v2 is. We can cross out the mass terms, and we can then whittle that down, and we can find what v2 is. V2 is going to be 17.1 meters per second. Okay, so now what we need to do is, since that v2 is all completely horizontal, we're told it goes up and it comes off a horizontal cliff. It looks like that in the image too from the book. So now we know that, we need to find how much time it takes to fall from the top of this cliff to the bottom. And to do that, we start off with our kinematic equation for an object falling. So we have our position, so we can have our position y is equal to y initial plus vy t plus 1/2. The acceleration due to gravity is negative 9.81. If we define positive to be upwards, t squared. Okay, so some things we can get right off the bat. It goes to a final position, to final height of 0. The initial height is 11 meters. The initial velocity in the y direction is 0. And then plus 1/2, negative 9.81 t squared. Okay, so solve for t, and we get t to be equal to 1.498 seconds. Okay, and then simply, since that's the time it takes to fall 11 meters, then that is also the time that required to move horizontally. So we just take our position. It's going to be equal to v2 times t, and that's going to be equal to 25.52 meters. And that's